So now I want to continue this exercise. So I just did part A, and then I will re-explain part B. So the question here is to calculate the angle between the face. When I say face, it means also the word planes, the same thing, ABC and BCD. So I'll go to this figure because it's more accurate. Now, the definition is to find the angle between two planes, two faces. It is the angle between two lines. Excellent. Those two lines, one should be in the first plane and the other should be in the other plane. Any two lines, not any two lines. Those two lines should be perpendicular to the intersection of those two planes. So first of all, the first thing that you need to think about is to find this intersection. Where those two planes ABC and BCDE meet, I can easily know that from the letters. Which two letters are the same on the both planes? The two letters are BC. So excellent. It means that those two planes they meet at BC. Now, I need to look at a line in the plane ABC perpendicular to BC. This line is AM. Why it's AM? Because we know that in an isosceles triangles, we know that ABC is isosceles. We know that. And, sorry for the handwriting, AM is a median. And what is about the median drawn from the main vertex in an isosceles triangle? So the median, you need to write it. I will say it. The median drawn from the main vertex in a right triangle is also height. So what can I deduce? I can deduce that AM, MA or AM is perpendicular to BC. Excellent, I got the first line perpendicular to BC. Now in the other plane, EBCD, which line is perpendicular to this intersection? The line is MO. And why? It's from the midpoint theorem I have here. M midpoint, O is midpoint because here it's a diagonal, guys. Here, if I join this, it's a diagonal, and O is the midpoint of the diagonal. The midpoint theorem gives me that MO is parallel to CD. And since here it's 90, so here it's 90. Two lines are parallel. If one is perpendicular to the first, so also it's perpendicular to the second. So I will repeat again. OM is perpendicular to BC. Since M is the midpoint of BC, O is the midpoint of BD, therefore MO and CD are parallel. But since CD is perpendicular to BC, so if two lines are parallel, if one is perpendicular to the first, so the other also is perpendicular to this line. So since CD is parallel to BC, so also MO is perpendicular to BC. So if two lines are parallel, any line perpendicular to the first is perpendicular to the second. MO and CD are parallel. Since BC is perpendicular to CD, so any line perpendicular to the first is also perpendicular to the second. So now I got the second line. So we're gonna be the angle between those two planes. So the angle of those, or between those two faces, is which angle? It is AMO. Excellent. How are we gonna find that AMO is a right triangle? Because it's an orthogonal projection. So, and in a right triangle, what did we learn? What can we do to find the angle? We need to use SOHCAHTOA. What do we have here? Which side is given? I have the opposite, yes or no? We have it. We have the adjacent because midpoint theorem, it's half of it, it's half of 20, it's 10. So I have the opposite and the adjacent. So when I have the opposite and the adjacent, what can I use? I will use the tangent. So I will remove this triangle out of the figure. It's like this. So it's like this. I have it. The triangle is like this. This is AOM, and this is the angle that I need to find. Here it's 15 and here is 10. And how are we gonna find the angle AMO, guys? So I need to use tangent AMO. It's equal opposite over adjacent. So it's equal 15 over 10. So tangent AMO is equal 1.5, and then I take my calculator, I will put on my calculator shift tangent 1.5, and it will give me that the angle AMO is approximately 56 degrees. So I will repeat again how I did that. I will repeat it again. So, as I said, to find the intersection between two planes, it is the angle between two lines, one in the first plane and the second in the other plane. And those two lines should be perpendicular to the intersection of those two planes. First step, what I need to do is to find what is the intersection of those two planes. And I can see easily that the intersection of those two planes is what I'm erasing to have it more clear, and then we can work with it. So the intersection of those two planes is BC. Excellent. Do you have any line in the first plane that's perpendicular to BC? Yes, it's AM. Why AM is perpendicular to BC? Because it's a median in a right triangle. And the median is also height, so it's perpendicular to the intersection. In the other plane, M or Y, using the midpoint theorem, first I have M midpoint, O midpoint, so those two lines are parallel. And any line perpendicular to the first is perpendicular to the second. Therefore, AM is perpendicular to the intersection of the two planes. OM is perpendicular to the intersection of the two planes. Therefore, the angle is AMO. I got it. So now I'm working in which right triangle? AOM. I need to use, I have the opposite 15 and I have the adjacent 10. Why the adjacent 10? It's the midpoint theorem, midpoint, so it's parallel and equal to half of it. And then I use tangent, opposite over adjacent to find the value of the angle. Now, we move to the last question. The last question is I need to find the angle between the slant edge AB and the plane BCD. No, angle between a line and the plane. We just have two properties to remember. Angle between two planes, angle between a line and the plane. We have another exercise like this, so don't worry guys, you will get it again. So now here, I need to find the angle between the line AB, the line, the edge, isn't it? Yeah, AB and BCD. So to find the angle between a line and the plane, it is the angle between the line and its orthogonal projection on the plane. Excellent. This is the line AB. Okay. If you throw, what does mean orthogonal projection? You are holding A and you throw it perpendicular to the plane. A becomes which point? It becomes O. It means the orthogonal projection, first B is still B. A is O, so the orthogonal projection of the line BA is BO. Is as the line is like this and I let it fall down. So we're gonna be the angle, it's this angle, guys. So the angle between the slant AB and the plane is ABO. Also again, here I have a 90-degree angle. This side is 15. How are we gonna find the angle? I need to do SOHCAHTOA. We need sine, cosine, or tangent. So we're gonna use tangent, opposite over adjacent. So how are we gonna find the angle? Tangent ABO is equal opposite over adjacent. So it's equal AO over BO. Okay, excellent. I have AO 15. How are we gonna find BO, guys? Can I find BO like this? No, I cannot find it like this. Where are we gonna find BO? As I said, it's already here a square. So here the base, it's a half a right triangle. Yes or no? And it's right isosceles. So if this side is 20 and this side is 20, I need to find the hypotenuse using Pythagoras, or if you know the property of right isosceles triangle. So how are we gonna find BD? I can write BD squared is equal BC squared plus CD squared. And when I will calculate it, I will have BD is equal 10 radical 2. And what's gonna be BO? Half of it. So what's gonna be BO? It's gonna be 5 radical 2. And all what we need to do now is to replace tangent ABO. It's equal 15 over 5 radical 2. And then also I will take my calculator. I will do shift tangent 15 over 5 radical. You can simplify it, could be 3 over 2 radical 2. And then I'm going to have approximately that the angle ABO is 47 degrees. So I'm going to repeat again. To find the angle between a line and the plane, it is the angle between the line itself and its orthogonal projection on the plane. It's as the line, I throw it perpendicularly. B gonna stay here. A, if I'm gonna go directly perpendicular, it's gonna be O. So the line BA becomes the line BO. So this is my angle between the line and the plane. And to find this angle all the time, to find any angle, I need to use outwork in a right triangle. The right triangle is ABO. So katoa, I will use here its tangent because I have the opposite and the adjacent, I can find it. The hypotenuse, I cannot find it. How are we going to find BO? It's half BD. And how are we going to find BD? We're going to find BD in the triangle BCD. It's a right triangle. It's right isosceles triangle. Pythagoras, 20 radical 20 squared plus 20 squared. And I will get what I want. Now we move to an easier exercise. Number 5, it's easier. I need to find the angle between the diagonal FD and the face ABCD. And the same thing, the angle between a line and the plane. It is the angle between the line and its orthogonal projection on the plane. We're gonna be D? D gonna stay here. We're gonna be F? B. So what's gonna be the angle? The angle gonna be theta. Excellent. What we gonna use? We have this is 4. And this side we don't have it. Can I find it? This is 5 here, guys. And you know that the base is a rectangle. So here there is a right triangle here. So how are we gonna find it? Using opposite and adjacent. So I want to use tangent theta. It's equal opposite over adjacent over BD. Opposite, I have it 4. Can I find BD? Yes. Where are we going to find BD? We will find it in the right triangle BAD. It's right where? Right at A. Pythagoras. What gonna tell me Pythagoras? Pythagoras gives me that BD squared is equal AD squared plus AB squared. And all what we need is to replace. Guys, I'm not replacing because I want to finish it quickly. So it's gonna be radical 12 squared plus 5 squared. So it's gonna be BD squared is equal radical 169. So BD gonna be 13. And then I just replace. I'm just trying to go fast to finish quickly. So 13. And then now I can replace. So what's going to be tangent theta? It's equal 4 over 13. I take my calculator. I put shift tangent 4 over 13. And theta going to be approximately 17 degrees. If you didn't get it, guys, repeat the video guide. And it's not hard. You will understand. Now, exercise 6. I have here the figure here. Also, all the faces are rectangle or square. So ABCD is a square. BCGF is a rectangle. So I have too much 90 degrees. 4, 4, 8. Now, the first question A is to find the length AG. How are we going to find AG? Where are we going to find the side or the length AG? So now, if I want to find AG, I will work in a right triangle. Where I have a right triangle, let me join it. So AGC is a right triangle, guys. Yes or no? So I want to find AG. I need to have GC. I have it. And I need to find AC. Do we have AC? No, we don't have AC. How are we going to find AC? We're going to find AC using Pythagoras in the right triangle ABC. So first, you need to find AG. To find AG, I need to work all the time. We need to locate the right triangle. I need to work on the right triangle AGC. Excellent. And I know that it's right at C. So I will have AG squared is equal AC squared plus CG squared. But what is missing? AC. So step 2, I need to find AC. Where are we going to find AC? In which triangle? In the triangle ABC. And it's a right triangle at B. So I will have AC squared is equal 4 squared plus 4 squared. And AC squared is equal to 16 plus 16. So I'm gonna have that AC squared is AC is equal to 4 radical 2. So I got AC is equal to 4 radical 2. And now, can I replace it here to find AG? Yes. So I will have AG squared is equal to AC squared plus As I said, CG squared, I direct, I will write the radical. So AG gonna be equal to radical. AG gonna be equal to radical 32 plus 64. So AG will be equal to radical 96. So it's equal approximately 9.8 centimeter. Now we move to part B. Find the angle between the diagonal AG